Unit 6 is divided into two units, Unit 6A and Unit 6B. In Unit 6A, we'll be covering the Intro to Chemical Reactions, and Unit 6B will be covering stoichiometry. This is the first video lesson for Unit 6A. In this lesson, we'll be classifying chemical reactions. Take a moment to download Unit 6A class packet from my website and go to page 2. Motivation. Do Cl2 and 2Cl mean the same thing? They don't. Cl2 is one particle or one molecule. 2Cl means there's two particles or two atoms. So they do not mean the same thing. They represent two different things. If you look at the chemical formula, one of them has 2 as the subscript and the other one has 2 as the coefficient. Learning target. At the end of the lesson, I'll be able to classify different types of chemical reactions. Homework could be number 1, which is a Junipod based off this lesson. Just to review, coefficient shows the amount of molecules and atoms. That's the number in the front. Subscript shows the amount of atoms of each element in the molecule. That's the 2 for H2O. Keep in mind, subscript 1 is invisible. So how many hydrogen and oxygen are in 4H2O? In each water molecule, you have 2 hydrogens and 1 oxygen. Remember, subscript 1 is invisible. So since we have 4 water molecules, we have 8 hydrogen and 4 oxygen. Can coefficients be fractions? No, they cannot. You cannot have a fraction of a molecule. Just to review, a chemical formula or a molecular formula indicates the type of atoms and the number of each type in a molecule or compound. For example, you have N2H4, that's a chemical formula of a substance. You have 2 nitrogens and 4 hydrogens in this compound. Empirical formula is a formula giving the simplest ratios of the element present in the compound. Keep in mind, the ratios may not be the actual numbers or the arrangement of the atoms in the substance. For example, if your molecular formula is N2H4, your empirical formula will be the simplest ratios of that, which is NH2. To get NH2, you have to divide all the subscripts by the greatest common factor of the molecular formula. The greatest common factor in this scenario will be 2. So if you divide all the subscripts by 2, you'll get NH2. Keep in mind, NH2 in this scenario is not a real substance. It's just the simplest ratio of this molecular formula. Learning check number 1. What is the empirical formula of P4O10? Pause the video and resume once you complete it. So the greatest common factor between 4 and 10 is 2. So if you divide everything by 2, you get P2O5. Answer is choice 3. Learning check number 2. Which formula is an empirical formula? Pause this video and resume once you complete it. So empirical formula is the simplest ratio. Therefore, it cannot be divided any further. So if we look at all these examples, choice 1 is the only example with a greatest common factor of 1. So the answer is choice 1. So take a moment to do 1 to 10, pause the video, and resume once you complete it. Okay, so here's the answers. So sometimes the molecular formula is also the empirical formula. For example, H2O. It cannot be divided any further. Now we're going to identify the different types of reactions based off the pattern in the chemical reaction. So each reaction has a pattern, so take a moment to label each substance as an element or compound. In the first one, hydrogen is an element, oxygen is also an element, and H2O is a compound. So the pattern is it went from 2 elements combined to 1 compound. In the second one, CO2 is a compound, carbon and oxygens are elements. If you notice, the pattern for reaction 2 is the opposite for reaction 1. For the third one, lithium is an element, NaCl is a compound, LiCl is a compound, and Na is an element. So the pattern here is element plus compound gives you compound plus element. For the last one, these are all compounds. So that's the pattern there. So keep these patterns in mind as we go through the different types of reactions. So there's 5 types of chemical reactions you need to know for the regions: synthesis, decomposition, single replacement, double replacement, and combustion. So let's start with synthesis. If you notice from the diagram, the magnesium and the nitrogen combine to 1 compound. So synthesis is when 2 or more smaller substances combine to form a larger substance. Here's an analogy from a movie, and here's another example. So you have two sodium atoms combined with a chlorine gives you two NaCl. Here's a GIF of a synthesis reaction. The next reaction is decomposition, which is the opposite of synthesis. If you look at the diagram, you have one compound break apart into two smaller components. So decomposition is a large substance breaking down into smaller substances. Here's another movie analogy. And here's a GIF. The third type of reaction is single replacement. So let's describe what's happening in the picture. In the beginning, you have one couple and one person by themselves, then they switch partners. So single replacement is when an element switches places with another element in a compound. In this example, is AB plus C gives us AC plus B. AB is a compound, C is an element, AC is a compound, and B is an element. So this is the pattern for single replacement. Compound plus element gives us compound plus element. So here's another example. We have sodium nitrate plus lithium gives us lithium nitrate plus sodium. Notice that the lithium and the sodium switch places, but the pattern is always the same. Compound plus element gives us compound plus element. Here's a GIF of the single replacement reaction. Notice that the magnesium atom displaces the silver atom. The fourth type of reaction is the double replacement reaction. If you analyze this picture, you start off with two couples, and one partner of each couple switches places. So a double replacement is when two elements within two compounds switches places to form two new compounds. So an example of this would be AB plus CD gives us AC plus BD. So notice in all cases, these are all compounds. That's the pattern for double replacement reactions. So in this chemical reaction, the lead and the zinc switches places to form two new compounds. So here's a GIF of the double replacement reaction. The last reaction is the combustion reaction. That's when a hydrocarbon reacts with oxygen to produce CO2, water, and energy. A hydrocarbon is a compound with only carbon and hydrogen. In every combustion reaction, you always have a hydrocarbon reacting with oxygen to produce the same products, CO2, water, and energy. If you have a different type of hydrocarbon, you will produce a different amount of CO2, water, and energy. Here's a GIF of the combustion reaction. Learning check number 3. This reaction is example of what? Pause the video and resume once completed. Since this compound plus compound gives us compound plus compound, the answer is B, double replacement. Learning check number 4. Given the word equation, which type of chemical reaction is present by this equation? Pause this video and resume once completed. So sodium chlorate is an ionic compound. It breaks apart into sodium chloride plus oxygen. Since it went from one substance to two smaller substances, the answer is 3, decomposition. For this practice, I want you to identify what type of reaction it is based off the pattern. Pause this video and resume once completed. Okay, here are the answers. So this concludes the video lesson for today. Remember to do the Junipod homework.